shape of this can, Coca-Cola can is changing?
Yeah.
Shape changing, okay. Here, this wall is coming like this wall is coming like this, and suddenly he applied a force by a rocket, not rocket, racket. Then
Mm.
the direction of the ball change, means force can change the direction of body. Now there is one more point. Uh, if a body is at rest, if you suddenly applied a force, then the body will be in motion. So due to the force, the body can be in motion.
Mm.
Okay, okay. This is the case. Due to the force, the heat can be produced. The heat can be produced. If you will apply a force, suppose this is some uh, block, this is some block or some object, and this person is applying a force in this direction. So due to the friction between this surface and the surface of this block, due to the friction, there is a term friction, heat will be generated, and we will discuss how this heat is generating. We will discuss how this heat is generating. Okay, so forces. Forces. So basically, first I will write the definition of forces, and after that we will discuss what are the types of the fundamental forces, and one by one we will discuss uh, the type of the fundamental forces. First, we should know what is force. So basically a force. You already know this thing. A force can be a pull or push or twist. Twist means suppose this is a pen and I am twisting this pen like this. This can also be a force. Pulling, pushing, twisting is also a force.
Yeah.
So, okay. Second point. Force is the cause of motion. Force is the cause of motion. It can change the speed of object. Force is the cause of motion. This mobile phone initially at rest. Now I am applying a force. This mobile phone is moving. Cause of the
Mm.
motion is applied force. So force is the cause of the motion. Okay. It can change the speed of an object. It can change speed of object.
Mm.
Basically, it can change the speed of object. For example, someone is throwing a bottle towards my hand like this. So what will happen? Initially, there will be some velocity. Finally, if I catch this, the velocity becomes zero, or the speed becomes zero. Speed of this bottle. Same is the case with the cricket ball. Batsman hits the cricket ball like this, and
Yeah.
you have catch that ball. And
Mm.
when you have catch that ball, initially when he hits the ball, there will be some velocity or speed. When you have catch that ball, speed becomes zero. Means speed is changing from some value to zero. So basically, it force can change the speed of object, and we can write it can move. It can move a stationary object. A stationary object. It can move a stationary object. There is one more point. There is one more point. It can produce, means force can produce heat. Force can produce heat. So we can take this picture. We can paste this here. It is shown here. Force. This person is applying a force, and here is the friction in between this block and this surface. So due to this friction, there will be a heat. So basically, what is happening here? I'm writing here. Why there is a heat producing here? When this person is applying a force, na, so at the interface here, there will be the molecules of this surface, and there will be the molecules of this block. When this person will apply the force, so this block will try to go in this direction, means there will be the rupturing of the molecules or the particles here. So these here the particle will have more energy. Here the particle will have more energy, means here the particle will move faster. At this point, when this person will apply a force, particle here will move with a greater speed or greater velocity.
Yeah.
Then you can say here the particles will have more energy, and due to that more energy, there will be more temperature of the particle, and due to that temperature, there will be heat generation. So we can write one point. Friction causes the molecules on rubbing surfaces to move faster. Means this is the surface, this is this block surface, and this is this surface. This surface has its molecule, and this block have its molecule. So when this person will apply a force, this surface of this block will try to move in this direction. Means, and this surface is this surface of the block is contact with this surface. So basically, what will happen? This person applied the force, and here the molecule here contact in between the two surfaces will move faster due to the applied force. So we can say when they will move faster, so we can say so they have more energy. Suppose there is one person in a room, there is another person in a room. One person is moving slowly, and another person is moving very fastly. So which will more energy? The person which is moving very fastly. Okay.
Yeah.
So here the molecules are moving fastly. So we can say they have more energy. So they have more energy. If they have more energy, due to the energy, the temperature of the molecule will increase.
Yeah.
Due to energy. For example, here suppose here is fire. This is fire. Na? Here is this bottle of steel, and in the suppose this bottle is of steel. This bottle is of steel, not of plastic. And here is this fire, and this is a condition. At bottom there is fire, and here is steel bottle. In steel bottle there is water. So due to the fire, you are supplying the heat, or you can say you are supplying the energy to the water. So what will happen? When you will supply the heat to the water, these water molecules will have more energy, and due to that more energy, the temperature of the water molecule will decrease or increase.
Decrease. If what?
Decrease, not decrease. It will increase, na. Suppose here is fire. Here is fire. Here is water. This bottle is made up of steel. and
Yeah.
you are supplying the heat energy to the water.
Hmm.
Fire is something called heat energy. Basically, fire is the heat energy. So these molecule, you can take the example of boiling of water.
Yeah.
In boiling of water, what happens? Heat energy is supplied.
Yes.
Heat energy supplied to the water. So water molecules get energy, and due to that energy, the temperature of the water increases or decreases? Increases, na? So
Increase.
same is the case here. Due to the friction, what is happening? This force is applying a force. So here the molecules becomes faster. Means the energy of the molecules is increasing. Due to the increase in energy, the temperature of the molecule will increase. And the temperature, if the temperature is increasing, means there will be the heat energy. Okay. So due to they have more energy. So due to energy, more temperature, of molecules in contact, hence heat energy will produce. This is the explanation. Here I have written force can produce heat. So this is the explanation how the force can produce the heat. So hence heat can be produced. Heat can be produced, or you can say generated. Got it, Rayyan?
Yeah.
A force can be pull or push or twist. Pull, push, twist. This is twist.
Yeah.
Twisting something like this. This is twist. Force is a cause of motion. I have told you. It can change the speed of object. I have told you. It can move the stationary object. I have told you. It can produce heat. I have given the explanation also.
Hmm.
Okay. Now there is the unit. So what is the unit of length? What is the unit of length?
Centimeter.
Yeah, of course, centimeter. So unit of length will be centimeter, will be meter, will be kilometer, will be picometer, will be decimeter, will be other units we have.
Hmm.
So unit of force we will take Newton. This is the SI unit. What unit? SI unit. SI unit means International System of Unit. So basically you should know SI unit of force is Newton. Now this is all about the force. After that I want to discuss there are forces in nature. In nature there are forces. For example, this is bottle and this is me. This is bottle and this is me. There is a force of attraction in between this bottle and this me. Okay. There is a force of attraction between me and the screen of this laptop.
Hmm.
We have seen the magnet attracts the iron. Magnet, if you have a magnet, the magnet can attract the iron.
Yeah.
Why? Because there is some force that we will discuss. What kind of force that is?
Magnetic force.
Yeah, magnetic force that is, but we will discuss this later. Okay. More example. Just this is a pen. Okay, just a minute. I have to take a pen. Okay, so see here. This is a pen. And why this pen is going in downward direction? Here, I have thrown this pen like this. This is again and again going in downward direction. Again, why not in upward direction? There is a force responsible for this phenomena also. There is a force for this phenomena also, responsible for this. There are any other forces also. Uh, do you know what is atom? Atom.
Yeah.
What is atom?
It's like
Mm-hmm.
where all the molecules are and stuff, like the
Mm-hmm.
electrons, protons, and neutrons.
Basically, you can say atom is the fundamental particle, smallest particle,
Mm.
or in an atom there are electron, protons, and basically I will discuss the atom today. What is atom? Okay, basically in an atom there is one nucleus, and inside the nucleus there are protons and neutrons, and
Mm.
around the nucleus electrons revolves. Around the nucleus electron revolves in circular orbits. So we'll discuss that. So I want to explain you. There are forces in nature. There are different types of forces in nature. That this pen is falling downward due to the gravitational force. Due to the gravitational force, and
Oh.
magnet attracts the iron due to the electromagnetic force. Due to the electromagnetic force. If you are taking two charges, if there is one positive charge, if there is one positive charge, so positive charge and positive charge will repel or attract.
Repel.
Repel. Very good. If I am taking a negative charge, if I am taking a positive charge, repel or attract?
Attract.
Attract. This is also a force. This is also an electromagnetic force. Okay. So now we will discuss. There are fundamental forces. Fundamental forces in nature. Fundamental forces. What is the meaning of the fundamental forces? These are the basic forces in physics we take to explain the different phenomena. Why these phenomena are happening? Why the iron attracts the iron? Why the magnet attracts the iron? Why this pen is falling downward always? So with the help of these forces, we can explain these phenomena. Okay. So basically, what are fundamental forces? So first, I will write the definition. So fundamental forces, we can say these are basic forces. These are basic forces in physics. Do you know we are studying the physics?
Yeah.
You are studying a science, but you can say it is a physics.
Yeah.
So these are the basic forces in physics that governs how object or particles interact with each other. Interact, and one more line you can write. These are the basic forces in physics that governs how object or particle interact, and how certain particles decay. Have you heard what is decay?
Yeah.
Can you explain it if you want? If you want, then you
Uh,
can explain.
decay, like when something goes bad, or like bacteria goes onto something and starts to decay.
Mm-hmm.
Like on this bacteria on your teeth has to like on your
Hmm.
gums
Hmm.
decay.
Means right now this is a pen, and if I want to see this pen after 10 years, there will be some decay in this pen. There will be some decay in this pen. Okay.
Yeah.
Very small decay, but there will be a decay. Decay means some particle will be removed from this pen. Okay. Okay. So We will discuss this. Actually, we have heard about the atom bomb. What happens there? Na? There are some reactions there, and there is a decay. There is a decay of some particle. Okay, so due to decay of that particle, energy releases in a large amount. So energy releases in a large amount, and that is responsible for the destruction. So we will discuss. So basically, fundamental forces. We have four types of fundamental forces. Number one, first is gravitational forces. Gravitational force. First is gravitational force. Number second is the electromagnetic force. Is the electromagnetic force. Electromagnetic force. Number third is the strong nuclear force. Strong nuclear force. Strong nuclear force. Number fourth is weak nuclear force. Weak nuclear force. So in physics, basically four fundamental forces defined: gravitational force, electromagnetic force, strong nuclear force, weak nuclear force. One by one we will discuss, one by one. Gravitational force. First, gravitational force. Gravitational force. This gravitational force is given by some scientist named Newton. Basically, what is gravitational force? Suppose this is a mobile phone and this is me, and this mobile phone has a mass. This mobile phone will have some mass, and I am also have some mass. I also have some mass. So, according to this force, according to this force, there is a force of attraction between me and between this mobile phone, because I am having a mass and this has a mass due to the gravitational force. In all the objects, there is a gravitational force. There is a gravitational force in all the objects due to the mass. Okay. Now, so basically, it is gravitational force. It is one of the four fundamental forces. It is one of the four. This is one of the force, na, in four fundamental forces. So we can write it is one of the four fundamental forces. It is one of the four fundamental force. And remember that I am saying that there is a force. See, this is your bottle. This is not your bottle. This is my bottle. This is bottle, and this is a phone. And you will say, sir, you are saying that this bottle have mass and this phone have the mass, and there is a force of attraction. You are saying that is gravitational force. But why they are not attracting each other? Why they are attracting or not attracting? Not attracting, na? But then also I am saying there is a force. I am saying, Rayyan, there is a force between this phone and this bottle. But if there is a force, so you will say they should attract. But that force is very, very, very weak. That force is very, very, very weak. So that force is not able to attract, because masses are very, very small. Masses are very, very small. That is why the gravitational force is very, very weak for small objects. Okay, so it is weakest of all. It is weakest force of all. I have given the example why it is weakest, because if for example, if this is a magnet and this bottle is made up of iron, or if I will take this pen made up of iron, then this phone has the ability, not this phone, suppose this is a magnet, this is a magnet and this is a pen. Try to relate the thing, try to, this is a pen and this is the magnet, this is a magnet suppose. So this phone will somehow attract this pen, somehow will attract this pen, na?
Mm.
And that force is known as the electromagnetic force. And why this why the magnet attracts the iron? Due to the electromagnetic force. But here you can see that these things are not attracting each other, so it is the weakest of all. You can say this force is weaker than the electromagnetic force that we will discuss later. So it is weakest of all. And one thing more, it is attractive in nature. It is attractive in nature. It is attractive in nature. So if I am saying there is a force, but they are not attracting each other, but they are attracting each other, but they are not. There is no motion like this. Okay, there is no motion like this. They cannot be in contact due to with the help of that force, because that force is very very small. Okay, so I am saying there will be a force and that force will be attracting in nature. Try to come closer these objects. Attractive in nature. Yeah. So now I will explain you little bit what Newton has said about this force. Basic things we will discuss. Okay. So what the Newton said, you should know how Newton uh, find this force. Okay. So basically, according to Newton's law of gravity, Newton's law of gravity, according to Newton's law of gravity, it states that it states that gravitational force it states that gravitational force between two bodies two bodies means you can take the example of this bottle and this phone, two bodies. The gravitational force between two bodies is proportional to is proportional to the product of their masses, the product of their masses, and inversely proportional and inversely proportional to the inversely proportional to the square of distance between them, square of distance between them. So what does it means? Means uh, suppose we have these two objects, this have some mass, this have some mass. If I am taking a product of mass of this and mass of this, suppose it will be come out to be 1 kg, 1 kg mass. And if suppose I am taking an example of sun and the earth, I am taking the example of sun, this is sun, and here is some earth is smaller than sun, so this is earth. Okay, just wait a minute. Are you getting my voice?
Yeah.
Rayyan, are you getting
Yes.
my voice?
Yeah, I can hear you.
Okay. Just wait a minute. Getting now properly?
Yeah.
Okay, just wait a minute.
Yeah, okay.
So this is your sun and this is your earth. This is your sun, this is your earth. And these are two masses, like small masses, like this is my bottle.
Yeah.
And this is my phone.
Hmm.
You can compare. These are two objects and these are two objects. And according to Newton, there will be a force between this bottle. Just we can draw here. There will be a force of attraction, that is gravitational force in this bottle. And there will be a force of attraction between the bottle and the phone. Okay. And there will be a force of attraction between the sun and the earth also. Because sun also have very large mass, earth also have very large mass. So according to Newton, suppose this has the mass m1, this has the mass m2. According to Newton, this force of gravitation is directly proportional to the product of the masses. And here also is directly proportional to the, suppose this is the mass of the sun, capital M, small m is the mass of the earth. So this will be the, so suppose, so which one will be greater? This force, this F will be greater, or this F will be greater? You can see the mass of the sun is very, very large. Mass of the earth is very, very large as compared to this masses. So according to Newton said that force of gravitational is depending upon the product of the masses. If the product of the masses is large, the gravitational force will be large. So in this case, both the masses are very, very large. Then the product of the masses will be large, na?
Yeah.
Here, the product of the masses will be very, 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 very small as compared to the product of the masses here. So you can say there will be a very, very strong force of gravitation between the sun and the earth. Why? Because they have large masses.
Yeah. Sir, from next lesson, can we do like questions? From next lesson, can we do questions on this?
Okay, we can do the questions.
Yeah.
Okay. So first understand, then we will do the questions. Okay.
Yeah.
M1 and M2. So basically, so I think, have you understood now? Have you understood this?
Yeah.
Okay. So according to Newton, force is directly proportional to product of the masses and is inversely proportional to the square of the distance. So suppose here is one mass m1, here is another mass m2. So force of attraction between the two masses will be given by F is equal to G m1 m2 divided by r square. G m1 m2 divided by r square. Okay. So this will be the formula. This is the formula of the gravitation force. Okay. What is this? F is the gravitation force. M1 and M2 of the masses. R is the separation. This is R. R is the separation between M1 and M2. R is the separation between M1 and M2. Okay.
Yeah.
So this is the gravitational force. So I will represent the gravitational force with Fg. Fg is the gravitational force. For an example of the gravitational force, the body, this pen is falling in downward direction due to the gravitational force. You can take the example of falling a ball on ground, or you can say revolution of moon around earth is due to gravitational force. This lecture is little bit theoretical, na?
Yeah.
I know. Because I have to explain the forces. That is why this is becoming theoretical. That is why we are not solving the questions today.
Mm.
So most probably in the next class we will solve the question. Okay. So this is the gravitational force. Okay, this is the gravitational force. After that, there is an electromagnetic force. Electromagnetic force. So what is an electromagnetic force? So electromagnetic force occurs between electrically charged bodies. Electrically charged bodies. So if you have a plus charge, if you have a minus charge, both will attract. So these charges are at rest. So this is due to the electromagnetic force. Okay, due to the electromagnetic force.
Okay.
So there is one example here. Suppose this is your atom, and inside the atom there is nucleus. This is the atom, suppose. And what is this? This is nucleus. This is nucleus. And around the nucleus, electron revolves. Around the nucleus, electron revolves. Okay. So electron have negative charge, nucleus has positive charge. So there is a force of attraction. There is a force of attraction between the electron and the nucleus. Okay. So here this force is also the electromagnetic force. So you can write here. It is the basic reason electrons are bound to the nucleus Rayyan, beta, this is your number.
No, sir, it's my dad. He said he wants to talk to you.
Okay.
Yeah.
Okay. When?
After class, if possible.
Okay. So this is WhatsApp number.
Yeah, and you can message him on WhatsApp and he'll call you.
Okay. So this is the nucleus, this is the atom. So basically this nucleus is positive charge and this electron is negative charge. Okay, so there is a force of there is a electromagnetic force between the electron and the nucleus. Okay, so it is the basic reason electrons are bound to nucleus and responsible for complete structure of atom. Okay, so basically this is the electron, this is the nucleus. So this nucleus will try to attract this, okay, because this is negative charge, this is positive charge. So means this nucleus is trying to bound this electron. So due to the electromagnetic force, this electron is bounded in the atom. Okay, so electromagnetic force is a combination of electric and magnetic force. We can write. So it is the combination of magnetic and electric force, and electromagnetic force can be repulsive and electromagnetic force can be attractive. Okay, if you will take two positive charges, then the force will be repulsive. Two positive charges will repel each other. One positive, one negative charge will attract each other. Okay, so it can be attractive or repulsive. It can be attractive or repulsive. Okay.
Yeah.
So this is the basic of electromagnetic force. This is a basic of electromagnetic force. Now we will discuss the strong nuclear force. Strong nuclear force. Strong nuclear force. This strong nuclear force is strongest of all the forces. Okay, and this strong nuclear force is responsible for holding the nucleons or protons inside the nucleus. Okay, so I will explain how. Basically, out of all four fundamental forces, nuclear force nuclear forces are the strongest attractive forces. Strong nuclear forces are responsible for holding the nucleus of atoms together. So basically, this is your suppose atom, and in an atom
Nucleus is there. Inside the nucleus, there are positively charged protons. There are positively charged protons, and there are neutrons also. Neutrons have no charge. Neutrons have no charge. So what will happen now? See, these protons will repel each other. These protons will repel each other due to the electromagnetic force. But there will be a force. There will be a force that compensates this force, and that force is known as the strong nuclear force. That force is known as the strong nuclear force. Okay. So basically, you can say a strong nuclear force is that force that holds proton and neutrons together in the nucleus. Okay, or you can say holds the proton and neutrons together in the nucleus. Holds the proton and neutrons together in the nucleus. There is one more force, last force, weak nuclear force. We will write 2 or 3 points. Okay, weak nuclear force. Name suggests as weak. This force is weak. Okay, so basically weak nuclear force is the force between the elementary particles. Okay, between the elementary particle, and there are certain processes that takes place due to this weak nuclear force. For example, radioactive decay. Radioactive decay is there. Okay, and radioactive decay is due to the weak nuclear force. Okay, so weak nuclear force weak nuclear force is the force existing between elementary particles which are responsible for certain process to take place. And this force is responsible for radioactive decay and this force, as name suggests, that weak nuclear force, this force is very weak. Very weak in nature.
Okay.
Okay, so this is the weak nuclear force, strong nuclear force, electromagnetic force. And now tell me, Rayyan, what is the electromagnetic force?
It's I don't know how to explain it.
Okay, so inside the nucleus, what are the particles inside the nucleus? Okay. What is gravitational force?
What gravity acts upon something. The force of gravity.
What I have told you, what is gravitational force? Gravitational force is a force of attraction between any two masses.
Yeah. Mm.
Okay. Electromagnetic force is a force between electrically charged bodies. Electrically charged bodies. Strong nuclear force is a force which binds the nucleus.
Yeah.
Okay. And weak nuclear force is a force, okay, weak in nature, number first, weak in nature, and responsible for certain process like radioactive decay. Okay.
Mm.
So these are the four fundamental forces. Okay.
Okay.
So just note me the number. Note
Yeah.
down.
Sir, you said you would send the link for the OneNote on there. WhatsApp, on the WhatsApp.
Okay, today I will send.
Okay.
And it is better to make your own notes. I want
Yeah.
that if you will make your own notes, that will be better.
Okay.
Means I will send you the notes, no problem. But
Yeah.
what you should do now, at least try to take the screenshots. Okay.
Yeah. Okay.
That will help you. If I will send you the notes, there is no problem, but that will not help you. If you will make your own notes, that will be the advantage for you. I am just giving the advice. Okay. So I will
Okay.
send you the notes, no problem. Just a minute. Just a minute.